Hi, I'm Ibo. I'm a PhD candidate at Defense Innovation Institute. I will present our work, Grounded Entity Landmark Adaptive Pre-Training for Vision and Language Navigation. Vision and Language Navigation, VLN, aims to train an agent to reach the target location inside photorealistic environments by following natural language instructions. Cross-modal alignment is one critical step to accurately make the action decision for the agent. Most previous works have focused on the global alignment of instructions and paths. Others have attempted to align sub-instructions and subpaths locally. But they are still at the sentence level. The next step is entity level, identifying landmarks that correspond to entities in the instruction. However, there is no dataset with high-quality entity-level grounding information. To address the above limitations, we introduce additional high-quality grounded entity landmark human annotations into room-to-room dataset, called Grounded Entity Landmark R2R, GL, R2R. To verify the value of our dataset, we propose a novel Grounded Entity Landmark Adaptive, GELA, pre-training paradigm, explicitly supervising the models to learn fine-grained cross-modal alignment between entity phrases and environment landmarks. The construction process consists of 5 stages: raw data preparation, annotation tool development, annotation guideline standardization, data annotation and revision, data processing. The annotation must follow 4 rules: alignment rule, free text rule, text coreference rule and unique landmark rule. Then we analyze the dataset. On average, each instruction contains about 4 entity phrases and 8.5 landmark boxes. As a result, the agent can use a variety of landmarks to guide their decision-making in each episode. Our approach is first adaptive pre-training a backbone pre-trained VLN model on proxy tasks and then fine-tuning it on downstream benchmarks. Adaptive pre-training is continuously pre-train a pre-trained model to learn the knowledge appropriate for a particular task or domain. Our pre-trained model is HAMT. We propose 3 adaptive pre-training objectives. The first is entity phrase prediction, which predicts the positions of entity phrases that correspond to annotated landmarks. The second is landmark bounding box prediction, which predicts the bounding box of the landmark that matches with annotated entity phrases. The third is entity landmark semantic alignment, which enforces alignment between the hidden embeddings of the landmark and entity at the output of the cross-modal encoder. After adaptive pre-training, we fine-tune the model for VLN tasks under the scheme of imitation learning and reinforcement learning. We conduct fine-tuning under 3 settings with different data augmentation. None represents without data augmentation, ST represents style transformation, SMO represents semantic class masking on synthesis environments. And we conduct experiments on 2 downstream benchmark, R2R dataset and CVDN dataset. Success rate and success rate weighted by path length are 2 key metrics. Firstly, we conduct detailed comparisons between GELA with HAMT on R2R dataset. GELA obtains obvious improvements both in SR and SPL under 3 settings. Then we calculate the attention weights received by each token from the corresponding tokens in the other modality in the last cross-modal transformer layer, defined as effective attention, EA, score. The results show that GELA achieves significantly higher EA scores than HAMT, indicating that the grounded pairs have a stronger correspondence in GELA. Our GELA model outperforms the state-of-the-art methods by a large margin both on R2R dataset and CVDN dataset. We conduct ablations on R2R validation unseen split to evaluate the proposed adaptive pre-training objectives and landmark categories. Among 3 objectives, only ELSA can improve agents' performance. The combined performance of EPP and LBP is much better than the separate performance, demonstrating that these 2 objectives are complementary. On the other hand, the results show that all 2 category entities can further enhance navigation, and objects contribute more than scenes. Thanks for your attention. Please visit our project page for more information.